Hello everybody, how's it going? Let's give it a second for everything to kind of catch up. Hello Johnny, hello Adam, hello Capo Steve, Henrik, Colin. How are all of you? Hello Michael, how's it going? Just kind of gathering my thoughts here. Not really. I'm just gathering some stuff to show you guys, make it a little bit easier in the long run. Hey Capo Steve, that's great. I don't hopefully we can do something interesting. I'm a little bit nervous about the stream today because we're going to be doing a bit of PCB layout, and yeah, I don't feel as comfortable doing that as probably some other people, and like I think Sion handles his streams well. I don't know how I'm gonna handle it, so we'll see how it goes. Hello Dustin, Dave, Embedded Hobbyist. We haven't started Embedded Hobbyist, so don't worry. Are your hands shaky? No, my hands aren't shaky. Like, Steve, I will just call you Steve. Am I really nervous? I'm like a little bit. I guess I don't really care all that much, but this could just go any which way. I just don't know. Hello, Rotor. How's it going? Okay, will we lay down a bit of a backstory? It's only 2 minutes in. I'll give it a second. What has everybody been up to? Hello, Alex. How's it going? I also, just before the stream, like ran around my house gathering parts. So I'm hoping I gathered everything that I need. Hello, Aaron. Ah, that ironic feather. That looks like it'll be fun. Yeah, I did a little bit of tidying up. I don't have as much stuff on the floor anymore. I need some form of furniture over there, but also I don't plan for this to be my office long term, so I don't know. Yes, my YouTube subscriber counter library is broken, and Johnny pushed a PR for that, which I have not accepted yet, but it looks like it's fine. Couldn't be any worse than what I currently have. Pile of stuff hid his counter with questions. That was why it's broken. Hello Jet, how's it going? Okay, so let us get into it. So okay, everyone's, not Johnny's, and Sion I think also fixed his, so there's at least 2 people in the world whose subscriber counters aren't broken. Yes, desk plus me probably. Why is a pull request called a pull? I don't know. Right. So this is my Ts100. I probably should bring my thing into manual focus mode. Just do that. Yes, do you pull in the changes maybe? I don't know why it's called a pull request. Good question. I think I overshot it there. And the old focus. Way overshot it, went the wrong direction. Okay, that's pretty good. Let's turn off low light compensation. But I guess you push your changes places, right? So I don't know why it's called a PR. Yeah, so this is my TS100. And my TS100 came with a barrel jack, similar to this, but not this, for powering it. It's a 2.5 millimeter diameter hole, right? I think that just means that is 2.5, and then it's a 5.5. I guess is that the larger thing. So one of the standard DC jacks would be 2.1. So it's not the it is a standard, but it's not the most common one. Yes, so mine came with one of these, and I used it for a while and was unhappy with how flexible it was. Like you can see with this one, it isn't that flexible, and it was quite heavy. It also had one of those, like, is it furroid or furroid? You know, one of those kind of plastic things that goes around your cable. You normally see it on the end of a laptop cable or whatever. I think they're called furroid something. Ferrite, thank you, Helio. So that also added to the weight. So I didn't really like that much. And other people had the same problem too. So what I did, and other people did as well, is they got one of these cables. So this is a cable you can buy off AliExpress. I think it's roughly about $10 delivered now. I think it used to be like 7 or 8 when I got it, but just with postage it's about $10, I think. And like, as you can see, this cable is super flexible and it's quite light. It's the correct cable on the end. So I was like, oh well, I could just get this cable and plug it in. Now I have a super flexible thing and it's light and everything's good. And now I just need a way of plugging these two in together. So this is an XT60 connector, would be pretty common in like drones and that kind of RC projects that can take like a massive amount of amps. I'm also waiting for a cable I ordered in like March or February as well. And I even paid like extra shipping for it from Banggood. It's one of my first times buying off them in a while. I wouldn't have any problems buying off Banggood, like in general, but I just tend to use AliExpress. Yeah, so I just got an XT60 connector and soldered it onto, or soldered it to a couple of wires. I don't know where that thing is anymore. I saw, maybe it's in like the box, isn't it? Yes, it is. That was convenient. So the next stage of my plan was this thing. So this just has a 2.5 millimeter jack on one end. I promise this is leading somewhere. And then you could plug it in to your cable that we got from AliExpress on the other end. And now, so you use your unflexible cable up to this point, and then you had your nice flexible cable from here on in, and that was all good. And so I made a video on the TS100. It was my first video to make with this microphone, and the sound was mostly in people's left ear. So it wasn't my greatest video for sure. So yeah, this is not a quality dongle. And I don't know why I never moved to the next stage of this. The next stage of this would obviously be create a PCB for it or something. Um, but I always had the problem that XT60 connectors are normally, I don't have one here to hand, but they're normally like the metal from it is down this way. And I was like, okay, so am I going to put it on a PCB and I'd have to have it like this almost? So like my barrel jack coming off to the side and my XT60 going up. And I was like, that wouldn't be fun. Uh, so I kind of parked it for a little while. And then I found these. They're obviously, I didn't have to look too hard for them, but they're right-angled XT60 connectors. And yes, I believe, Steve, that these are kind of for PCBs because they have even the little kind of, I don't know what you call this, a bit of extra support. I don't think it's for anything wiring wise. Hey, Bleep Track, how's it going? Yeah, so I got these and I made a PCB for it. And it's nicely referred to as my Ts100 Flexi Friend. So yeah, this is a really simple PCB that seems to have lost some of its solder mask somewhere along the way. I don't know how that happened. So you just put your XT60 here and you'll put your barrel jack over here. And then here is one I made earlier on a different stream. And yeah, so it's really simple, right? It just connects your barrel jack to your XT60. So it lets you make use of this cable. And you're all good. And you even have the heat shrink around it, so like no, nothing gets connected, nothing gets shorted. Hello James, how's it going? Flexi Friend, yeah. So I don't know why I called it a Flexi Friend. What else do you call it? Like, yeah. So I have been soldering using this for the last few months and everything's great with it. There's no problem. I was soldering with this for the like year before that, so nothing, no problems. But I think it was on Voltlog's channel. I'm not 100% sure that I came across that you could get these cables. So this is the correct barrel jack on this side. And this is a USB-C power connector on this side. And basically, there is a thing called USB-C power delivery. That's what this PD stands for. And if I bring over my Mac charger here, is this my genuine one? No, this is the fake one I have. Designed in China, made in China. I don't know where my real one is. It could be downstairs. Doesn't really matter. So you can see here that it can output multiple different voltages, 20.2 volts power delivery, 9 volts power delivery, and then 5.2 volts it can output 2.4 amps. So what happens is, in normal circumstances, you would plug in your phone, right? And so my phone supports quick charge or whatever that thing is called. So my phone will actually negotiate 9 volts off this charger, and it will charge faster off this one rather than a regular USB charger. And when I plug my laptop into this, it will pull 20 volts, and yeah, so that's called power delivery. And yes, so Michael is mentioning it in the chat that there is an IC you can get to negotiate power delivery for you. So like when I plug in my laptop, it negotiates with the charger to say, hey, I want 20 volts. Can you give it to me? And if the charger goes, yeah, I can give you 20 volts, everything's good. It gives 20 volts. And same with the 9 volts and same with the 5.2. So it doesn't do all these at the one time. It does only one of these. So it's not like a PC power supply where it's given 12 volts and 5 volts and whatever, 3. Does it give 3 volts as well? It does one. Like the device negotiates it and pulls back whatever it needs. So I was like, well, the Ts100 could surely do this. So Jan has a project, I can't think of a second name, and I can never remember a second name, called the Otter Iron, where he replaced the entire PCB of the TS100 with a new PCB that had USB-C instead of micro USB, and he could power it using USB-C. But I'm a little bit hazy over when I came up with what ideas or when I decided to do things. It could have well have been after seeing his project that I decided to do this. So I'm gonna say it was, because I don't know. And I was like, so that's super cool, his project, right? But it's oh, hey, Paul. Yeah, I must put chat up on screen. I don't have that at the moment, so I'm not going to set it up now. But I'll set it up for the next time, I guess, down here somewhere. Yeah, so, like, it's a big project, his thing. Like, as in, you have to solder all the components in, and then there was also kind of questions about, like, the connectors for the heads themselves. Like, he couldn't find a perfect replacement for them, and like sometimes you were taking it from, you know, a donor TS100 or whatever. And I was like, well, there's nothing wrong with the TS100 itself, so could we just move the USB-C part further down the line, you know, as in, so instead of like a flexi friend, you have a USB-C connector here instead of the barrel jack, and you have your IC that will negotiate with the charger to say, hey, I want 20 volts. And yeah, so this most simplest proof of concept was buying this cable, which has, I don't know what IC in it, but it does negotiate 20 volts with your charger. And yeah, so that works perfect. That's how I have been soldering with USB-C for the last couple of months now. A Flex C friend. I'm stealing that. Well, possibly anyways. So the problem though, so if you just buy this cable, I think it's a $5 or something. If you buy this cable, you can plug in your USB-C cable. There is, I have a USB-C cable on the floor here. I also have a power bank. I think I showed this on a couple of streams before, but this power bank is capable of doing 60 watts, so 3 amps at 20 volts. Yes, you can have all the royalties, Dustin. So I can plug into my power bank here, so just my USB-C cable plugged into my power bank, and I plug in my USB-C here, and there my iron is turning on. Let me just get my stand first. I have no idea where my stand for it is. Oh, here it is. Right, so, right, this is off a power bank now, so we're, like, you know, we're wireless, almost. Hey Aaron, how's it going? So, let's show how quick this heats up. So this is from cold, and it'll probably go to 350. I'm not sure exactly what it's going to heat up to. But, as you can see there, it's booting along. You can see a little bit of smoke in my screen. There it goes up to 380, and like, that was fast, you know, there was absolutely nothing wrong with that. So I have been soldering with USB-C. Hey John, how's it going? I've been soldering with USB-C since I moved. Well, I was doing it just a test before I moved house, and I haven't bothered setting up my soldering cable or the power supply from my soldering iron in this house. I've just been using USB-C and this. So the problem with this is, so it works fine. It heats up the iron fine, but this is way too heavy. The cable is not flexible whatsoever, and by the time you have like another cable hanging out of it, which is also not that flexible, it's not a pleasant experience at all. But what I've been doing is I've just been using my Flexi Friend. So I have my USB-C cable plugged into this cable, which is plugged into my Flexi Friend. Right, and this is working 100%, no problems whatsoever. There's too many junctions, as Maiko says. Yeah, so it's not that big of a deal because like you kind of put it to one side and you just have this thing is the only part of the cable that's moving around. But I want to get rid of this part of it. I want to be able to plug the USB-C cable directly into the PCB here and have it powered. So I have bought basically some parts to make a few small runs of the Flexi Friend. You could easily EDC this. What's EDC? Sorry about my kids in the background. They're going to bed. So soldering on the commute. Yeah, I guess you could solder on commute, yeah. But I just really like the idea of having like a power bank that can like solder for me. So this is why it appeals to me. All right. So that's where I currently am. And then so I was doing a bit of research. On power delivery ICs, and I came across this little guy here. Right, and this is an IP2721. Right, it's got USB-C here. This one is a 20 volt one. If the human body has a high enough voltage power, I don't think so. So this one does 20 volts apparently, so we can verify it here. This is one of the things that I want to do. Basically, so the IP2721 is a chip that does power delivery. Depending on how you connect it up, it can do. It isn't kind of user configurable almost, like as in depending on what jumpers you place, it can decide whether it's doing 20 volts or I think 12 volts or 5 volts. We'll look at the data sheet in a minute. But like it can't be configured after it's powered on. As far as I know, I think we read that in the translated one. Like if you look, Great Scott has a video on some of the power delivery modules, and this is one of the ones he uses. And this one has a microcontroller on it as well, and you can like press this button and it'll change the output. But I don't want one of those. Like I only wanted to negotiate 20 volts. Oh, did you release a video on that, Aaron? I really want to watch that. My D1 HID shield is sitting on my desk here, but it has not been receiving much love lately. I must get back to it. Yeah, so this IP2721 seems to fit the bill. It's difficult to. I probably won't watch it now, Aaron, but thank you for linking. Yeah, so this one, This one is kind of perfect in the way that it doesn't, like, there's no user interaction. They can't accidentally put the wrong power through something, right? So it's just, I want 20 volts and that's all I want. And this thing will also go, okay, if you can't give me 20 volts, give me the next best thing. And the Ts100 can work between 12 and 20 volts. So if the power bank can deliver 15 volts, that's okay. Yeah, also I'm probably happy enough that the Ts100 can do whatever it wants. Like, if you don't provide it enough power, it probably just won't turn on, right? So that's okay. And the max a USB-C can deliver, or should deliver, is 20 volts, so we should be okay. Tried using a 555. I haven't tried using a 555 to negotiate power delivery. So what I want to do today, so I'm going to show you kind of where I am with this project. So let's do screen share plus desk. Yes, I'm a bit high up. It's the perfect time to fix this. It is live on stream. You don't need to see my terrible hair anyways. Come on. There we go. The TS100 is anything in between those, Adam. So if you provide, it can do 24 volts, and if you provide a 24 volts, it will heat up faster, and faster than just like twice as fast as 12 volts, because the heating element is a fixed resistance. It's 8.5 ohms. So if you do Ohm's law on that, so if you have, say for example, 20 volts, so if you have a 20 volt supply like we will here, if you take V is equal to IR, so you pull R over to the V side, so if 20 divided by 8.5 gives you basically 2.4 amps. But if you did 12 volts divided by 8.5, it's only like 1 point something amps. So the power it uses at the lower voltages is way, way less. I wouldn't recommend using 220 volts. Yeah, so here is the circuit I have, and I guess maybe I'll go to the zoomed one, zoom screen share, and I'll just move it across. Yes, that looks a bit better to me. Okay, so here's the circuit I have, and this came from the IP2721 datasheet. I don't know, for whatever reason, PDFs don't seem to work too well for me in Firefox, so here it is in IE of all things. And it's basically just this sample circuit, and this table here basically tells you that if you leave 5 volts connected to ground, if you leave the select pin connected to ground, it's 5 volts. If you leave it floating, it's 15 volts, and if you pull it up, it's 20 volts. I can't read Mandarin, I just threw it into Google Translate, and you can see here, high level, 20 volts. So there's two different types of this chip, an IP2721, which can do 20, 15, and 5, and an IP2721 Max 12, which can do 12, 9, and 5 volts. So this is basically the example circuit copied out. It's pretty straightforward, I guess. Like I literally just copied what they suggested to do here. I don't know if anybody has any questions about about that. I don't know even what I can say. It's been a while since I did it. So one of the things I found kind of interesting as well, and I was kind of racking my head around, was, so there's an NMOS here, which is, I presume is an N-channel MOSFET. IE, Internet Explorer. Yeah. I wonder, like, I guess it's possible that there's people who have never had to use IE before. So .ie is Ireland, but IE is Internet Explorer. IE is for an example. Yeah, I don't know exactly how to use it. So you normally say EG for an example, but there is situations where you use IE, but I don't know what those situations are, to be honest. Yeah, so if we go back to my desk, desk plus me, Grammarly. So when I received, actually even before I received this, let me zoom us in a little bit. Configure video, camera control, focus. So when I received this, or even before I received it, I was zooming in on it and was doing a little bit of reverse engineering on it. And can anybody tell me what is different between this and this? Where is it? Let's just get rid of, move me down for a moment. There's no MOSFET. In other words, that makes sense. There's no MOSFET on this. And I was like, why? How do they have, like, what's with the no MOSFET? So basically, what I think the MOSFET does, and I can't say that for sure, but I think the MOSFET, like, basically, I think the chip reads the V in, and if it's not what it expects it to be, it doesn't allow it go through to the far side. But I don't know that for sure. So, for example, I have a different version of this cable. Where is desk plus me? I had a different version of this cable that was literally just like USB-C on one end and the thing on the other. It didn't have any IC in it. And like if I plugged it into my regular phone charger, which is just like a standard USB wall wart, there's also reverse polarity protection. Oh, that's good, John. If I plugged that other cable into my phone charger, which was USB-C, 5 volts would come out on the barrel jack. Hey, Defpam. But if I plugged it into my Mac charger, at least my real one, nothing would come out. So I think what was happening was the Mac charger basically was saying, hey, I can't negotiate anything with you, so I'm not going to pass through anything. So I think I was guessing that it was a failsafe around that if it negotiated the wrong thing, it wouldn't just let that flow through to the device. Like, it would only be the thing you'd expect it to be. But I didn't know that for sure. I doubt it is integrated because it's the same IC that's in the this sheet. But John Raymond is saying that the MOSFET is for reverse polarity protection, and I guess maybe that's true. Like, one of the problems with USB-C, right, is that power can go either direction, right? But yeah, so I don't know. I can't find any information on this data sheet to what the NMOS is doing, but yeah. So I had plans to possibly like breadboard out this, but then I was like, I don't think I want to do that. So what do I have here? So I have like a USB-C breakout. Desk plus me. I need to zoom out the focus bit. I have a USB-C breakout, and I was like, I could just use this to do the thing. I got myself some IP2721s, and I have like some of the other parts as well that I need to build this. And I was like, do you know what? I think I'm just going to design the PCB and just order it, right? And if it's wrong, I'll just order another one. But if it's right, well, even better. Speaking in IKEA. But before I start that, what I want to do is I want to solder this up to a flexi friend, basically, and check whether it has, whether it's capable of powering the TS100. There's no reason why it shouldn't be able to. NMOS can't do reverse polarity protection in this configuration due to the body diode. I don't know anything about this, so I can't say one way or another to what that NMOS is doing. I think I'll probably include it, but I don't know. So Dustin's saying that it can't do reverse polarity protection. Yeah, I think we did read on the translated one what the MOSFET was doing. Let's see if we can find that out. Desk, or what is it? Screen share. The select pin is floating. Yeah, that's fine. Power path control. Oh yeah, this is it. Supports an external NMOS power tube, and the gate of the end of the NMOS is controlled through the V bus G pin to the control power path opening. Opening close. Turn on the power tube after the CC connection is established, and turn off the power tube after CC connection is disconnected. So yeah, I think it is like, if it doesn't negotiate something, it will turn off the power. That's fine. I think that makes sense, right? If it's not doing what you'd expect it to do. It probably isn't that important for my use case though, so I'm wondering if I should go the way of the little Chinese module and not include it. But then again, it's not a big deal to include, so maybe I just include it. So who knows? Yeah, so what I was going to do was I was going to solder up one of the flexi friends. Where are we? Desk plus me. I was going to solder up one of the flexi friends. This is one that has a screw terminal instead of the barrel jack. This will make it a little bit easier to just, I don't know, connect this to that, and we'll see how it goes. Yeah, why not? I guess I could also have a power tester that I think is capable of testing up to 3 amps. Maybe it's 2 amps. But yeah, I don't know if I need to do that. I guess I could just use the TS100 and see what happens, right? So yeah, my plan is to solder this, solder wires from this and connect it to this TS100, a flexi friend, and then connect my flexi friend to my soldering iron and make sure that this is able to power this. And I also have this terrible thing that if it works, maybe it doesn't work. Oh, it's working. We can check what temperature the chip is. 29.1, that seems high. Accepting it. I'm not accepting pull requests now. No way. I had a little a USB-C little board for testing, like power draw. I have the instructions for it here, but I don't know where the actual board is. It could be anywhere at this stage, so I'll just leave it. It is very echoey because it's quite empty in here. It's a relatively large room. I guess it's probably about 4 by 4 meters, roughly. And there's basically only stuff on this wall, the one that you're on. So it is echoey, yes. Poor Brian in his castle. I'm sorry. It is not cold. It's 100% not cold. It's very warm in here, I would say, even. Okay, so let's get soldering. So I have. I'll solder some cable to this, I suppose. I probably won't be able to fit anything through the holes, so I'll just solder them beside the holes, I guess. Yeah, and I'll solder up the Flexi Friend properly, because I wouldn't mind having. Oh, do you know what? I won't use the Oshpark ones. I'll use these ones, which probably look the same as the Oshpark ones to you guys. I'm like loony. What about loony? Yeah, I'm very unhelpful. Oh my god. Guys, if you could come help me move, I'll accept all your pull requests. I was streaming basically all of yesterday. Yeah, so this is some matte black of the Flexi Friend. The screw terminal one. I've got big fat just the edge rail seems to be a lot looser than the V-score on the actual PCBs. Or sorry, a lot tighter. Not helpful. Yeah, exactly, Christopher. Hey Sven, how's it going? I guess this also will prove out if the footprint works with them, and it does. So let me just get a screw terminal. Yeah. Oh, I know, Gavin, that you're only joking with me. I should also queue up a PR for the rotor. Was it you that made? There either was a PR or somebody had made changes to the PCB tree where they added a load of new like functionality to it, which I thought was super cool. I mainly took that from Dave Darko. I had memories of like doing more to it than I actually did, because my daughter has been playing with his slot badge a little bit recently, and like it basically has a lot of the same stuff as I have on the PCB tree. I thought I'd changed more stuff, but obviously I did not. So sorry, Dave. Oops, did I knock something? No, it's fine. Okay, so I guess I will do the plus first. So this is with my being powered off power bank. Let's get you a little bit closer. Get you a little bit more focused. Hey, thank you, Mark. Really appreciate it. Not something you had to do, seeing as you've half written my Spotify library, which we will get back to, but I just wanted to get kind of wheels in motion on this thing. I also wanted to change it up a little bit because I'm sure not everybody likes coding streams. I know some of you do, but I thought it'd be cool to do a PCB type stream or a product stream. I would normally be wearing goggles, but I don't know where they are, so I aren't. Which is the best excuse for not doing PPE. So I don't know where they are. Oh, this is quite warm. Just trying to make sure that it's flat. Yeah, it's pretty flat. I don't know, was anybody watching Bitlooney's stream? I think it was on his trash channel, where he was trying to he was soldering with a battery powered soldering iron, and it was pretty decent for like the first, like, I don't know, five solder joints, and then it started going to absolute crap. Thank you, Dave. I was actually almost thinking of going full circle with the tree, right? You got the slot badge from like, a lot of your slot badge was inspired by was it Unbearables or something on Pi Moroni? I was actually thinking of, hey, maybe someone like Pi Moroni would be interested in selling kits of it. So yes, that might be on my to-do list, to contact them, to go full circle. Hey Sion, how's it going? We're just soldering up a flexi friend here. I don't know what color I'd use for these in normal circumstances. Maybe black, or maybe red. I don't know, green. I have some green somewhere. Yeah, maybe green would do the job. Okay, looks alright. I don't really care too much if this is straight or not. I just want it done. Yeah, they did have a different chip. Do you know what I was looking at today? This is not flat whatsoever. It is annoying me. Do you know what I was looking at today? And they're actually pretty cool. I like the form factor. Is the I don't know how to do this without getting burnt, but the Circuit Playground is a nice form factor of a board for somebody. Like, if I wanted to get someone I knew who was like able to program into electronics, I think something like the Circuit Playground is a really good idea. It just, it has, oh, it's pretty crooked. Let's just not worry about it. It's pretty, like, it has like neopixels on it, has an accelerometer, has a microphone, I think. It has a speaker. It just has stuff on it, like, as in, you don't need to connect up. And, if you want to get somebody into it and just building projects, that'd be a pretty nice way. The only thing I think it lacks for me is Wi-Fi. Like, as you probably are well aware, I'm a big fan of Wi-Fi in projects. So yeah. Okay, so now I'm just going to solder a little bit of cable to this thing, and it's going to be the opposite way around, which is interesting. And then we'll connect the two of those together, and we'll see if this IP2721 will power the Ts100. I have no reason to think it won't, but why not prove it out? And then when we are finished this, we will move on to trying to finish the PCB. I don't have it routed basically at all. So yeah, that might be a bit of fun. I'd like to order them. I'd like to order them like tomorrow if I could. Like I'm not even worried if I have the final version of the board, like with everything I want on it, but I would like to prove my circuit out. So I'm gonna order these boards without breadboarding them. Hey Crocoduck, how's it going? I'm gonna order these boards without breadboarding them because I have to order off JLC anyways. Get you into what I'm doing here. I have to order off JLC anyways, and like I don't mind kind of just spending the few dollars or whatever on these additional set of boards. I normally have a better wire strippers, but this was the first one I saw in my storage bin. Hey Ansh, how's it going? Am I pronouncing that right? Ansh? I might just use the perfect. I just use the flush cutters. This is the one that came with my printer, I'd say. Do a slightly bigger one on this side. Ooh, Mark is routing a board. Can you talk about it, Mark? What are you routing? But yeah, I'm half considering making something equivalent to the Circuit Playground, but for Wi-Fi. I kind of started something really similar to it before. Like I guess you'd use an ESP32, because if you used an ESP8266, you wouldn't have any pins left by the time you connected all the other sensors. Right? No, my yeah, what that's a reference to is I have these automatic wire strippers, and I think basically like the black cable of my wire set has like slightly thicker or slightly harder casing than the other colors, so it doesn't strip it as well. Right, I don't know what to do here. I'm just gonna place it down gently and solder it there and see what happens. Yes, the ESP32 S2 is the way to go, because the main reason is because the only thing is I think Adafruit will probably also do something with that, because you would have, well, eventually you'll have Arduino support and Circuit Playground or Circuit Python support. So that'd be good. That seems pretty cool. David Watts had an idea. I can't remember where he talked about it before, but I really liked it. It was basically, he was talking about making a board. I think it had a little OLED on it or something, and was in a tiny or something, and you could just connect it up to the serial monitor or the serial pins of projects. And so where normally you would have a serial monitor, like, oh, what is going on here now? I lost a resistor. I might have to rewind through my stream to see where that was. I presume it was connected up. Let's see. See my slightly slanty resistor. I have to go into the other room to get a tweezers to fix that. Oopsies. Yeah, I guess maybe I need hot air as well, so I'll be back in a second. I hope you all behaved while I was gone. Yeah, that makes sense. That they're making a CPX. What time is it? It's just about to turn 10. I'm in Ireland. 10 at night. Do I want to use hot air? Probably. I guess I'll show you a little bit better what I see. See that resistor there has gone walkabouts. Hot air is the right thing to use here. I'm just trying to put off using it because I don't want to have to make room for my hot air station. So I only have, how many of you seen my office tour video? It's tea time. Yeah. How many of you seen my office tour video? So I only have one of my desks set up. So I definitely have a lot less room for stuff. I'm gonna have to pull you out a little bit. Actually, I can maybe tilt you. It's just because I need to be able to hot air in here. It's very late for you guys to be on. I'll show you my hot air station in a second. Hopefully you can still hear me alright. I don't really know what I'm doing with these hot air things either now. Seems quite hot. Right. I successfully removed the resistor. So now let's just get a bit of flux. You can't see a thing. Apologies. Let's just get a bit of flux and see if we can place the resistor back on. I don't know what these are. Probably 0603 maybe. Nice hair dryer I got there. Yeah. It does seem quite loud. It definitely feels hotter than my other one. That's the wrong side to approach this from. My flux pen is rolling away. I'm struggling to put it into the correct place. And I'm struggling to keep E in shot. So it needs to go up here. But I'm kind of sticking to the ground pad when I go up that high. Maybe I'll use the soldering iron for it. Yeah, I get the full. Well, my hair couldn't get much worse, so maybe I should be using soldering tools as my hair care products. Turn on, please. It's complaining about the temp. Okay, it's heating up now. Nose hair trimmer. Oh, that sounds awful. Oops, alright. It's kind of tombstoned a little bit. It is slightly tacked down, so I guess my worry now is I might rip the pad. I think that's back in. Let's just try and reflow it a little bit more. This is where a microscope would be great for both me and you. I'm gonna assume that's back in. I don't even know how I would verify that, but I'm just gonna assume it is. What size is the resistor? I think it's 0603. I should tin the head of my iron. I'm so out of space on my desk. I feel so constrained in every direction. Hey Rob, how's it going? 0603. 0603. Yeah, look, I'm gonna assume this is working. There's a very simple way to test that. We check, does 20 volts come out of it? I'm just gonna snip this. Gonna snip this. Right, let's get my how small can you hand place? 0402, isn't it? Or 0402. Yeah, resistor wise, I have normally only done 0805. That's what's on basically all of my kits and stuff. So I'm just getting my multimeter here. 0201. Like, by hand, is that without magnification? Because that seems very small. That seems like grains of dust. Yeah, I'm pretty certain it's 0603. It seems smaller than the PCB 3 ones, but it doesn't seem that much smaller. So that's why I'm saying 0603. I'm gonna go straight again now. So we'll. Right, so we're measuring 0 volts. I'm just gonna get rid of my hot air station. It was cheaper for me to buy a hot air station with a soldering iron than it was to just buy a hot air station. So I have a hot air station on its own, but I wanted to buy a spare one because I was using the hot air station for assembling power blockers, just to apply the heat shrink to them. And I was like, hey, I'm gonna have a problem if this ever stops working. No, I much prefer the Ts100 to that. Okay, so I'm plugging in USB-C into the thing, and as you can see there, it negotiated 20 volts. So we're getting 20 volts, so whatever that, can never get enough hot air stations. I think 2 is probably enough for me. Yes, I quite like this meter. Its continuity mode isn't great though. I think mine is faulty. You don't need 24 volts. 24 volts is the best it can do. Like, it'll heat up the fastest if you have 24 volts, but 20 volts is perfectly fine. Most of the ones that come with power supplies come with like 19 volt power supplies. So the TS80s is an 18 watt iron. So it uses QC USB-C mode, which is not the common one. The common type of USB-C for like larger voltages and stuff is power delivery. So the TS80 doesn't support power delivery, so you can't, like, there will be some power banks where you can use it. Any ones that support the Qualcomm, I think it's Qualcomm 3 or something that it supports. But like, you wouldn't be, as far as I know, and I'm open to being corrected on this, you couldn't sugar. Do I have a? I do. You wouldn't be able to power it off your Mac charger, for example, which you could with this solution. So yeah, the other thing I mentioned there was the 18 watts. The TS100 can do 24 volts at like 2.8 amps. I don't know what that works out in wattages. Is it 65? But like, this will be able to do 2.4 amps at 20 volts. So that is what, 50 watts ish. So it should be able to provide more power, but I don't know. I'll leave that up to smarter people than me to decide if that's true or not. But the logic seems alright. Uh, 1 watts is bad enough. David. Let me just cut down this black one. It doesn't need to be that long. What? That was yeah, he made that joke in his projector video, right? Why not desolder the terminal block and solder the cables? This is just a proof of concept. Like I could use like this Ts100 Flexi Friend screw is potentially a product. I don't think they will sell anything, but I'll probably make them available if anybody wants one. So this way, like you could, it's just an easy way for it to be powered off your off like say a lab bench power supply or something along those lines. Yeah, but David in his projector video, he said he made a joke about there's been 2 watts on screen when there was a picture of him and his brother, and I was like, you clever bastard. I suppose I could have used the other one. That doesn't matter. I have 2 of these flexi cables because I bought one off a supplier to test it out. What wattage is that? Multi-watts. So it's not the exact same as the one I got. Like, or maybe mine has just been smoothed out roughed up over time. This is kind of shinier than this, but they do seem to be about the same flexibility, so I'm not too worried about the shininess of the cable. So I'm happy with these, with the ones that they suggested or came back with or whatever. Like, it's definitely flexy, so I'll try it out. It's a little bit stiffer to push in, which will mean it'll be stiffer to pull out. It was okay. Relatively stiff. That's okay. How much power can you get across your FlexiFriend PCB? Good question. Let's find out. Let's take a little break and find that out, because this is going to be a question I'm going to have around the USB-C one. Alright, so here's my FlexiFriend. FlexiFriend, they're both basically the same. Here it is, FlexiFriend. Alright, so I have a 3mm trace. So if I go to trace width calculator, so if say I wanted 3 amps, I'm only gonna go with 1 ounce. I only wanted to go up 10 degrees. Like, required trace width is 1.37. Let me just zoom in on that. It's an external layer. Required trace width is 1.37. I've got 3mm, so I should be able to do double that even. No, not quite double. I can do 5. So 5 amps, which is way more than the Ts100 can take, so should be pretty safe with that. No, you're dead right to be thinking of it. So the VCC is is a trace, and then the entire bottom layer of the PCB is ground, so it shouldn't be a problem. I guess I could probably do the entire top layer of the PCB as 5 volts. I don't know. I was a little bit worried that it would become a big giant capacitor at that stage, but like as I mentioned, that should be that should be tons. Like I shouldn't have any problems, and like that's the trace width at 5 amps only going up to like 35 degrees, which is nothing. Like, as in, it should easily be able to go up more than that. So yeah. Yes, I also made it 3 millimeters just so I'd have to pronounce 3 millimeters over and over again. Okay, so let's chat more powering my TS100. I don't want to power it just yet. I suppose I could plug it into another flexi friend, right? I'm worried about plugging it into my only TS100. I'll just make sure that I don't have a short or something stupid like that, because that would be a disaster. I guess I'll just power it on, right, while I have heat dissipation. That would have been looked after by that trace width calculator. That's one of the things it takes into consideration, is how hot you want it to get. Okay, so I just have the probes of a multimeter shoved into the wrong way around, into the XT60 connector. And I'm going to plug in my USB-C cable. Okay, so we have 20 volts coming out. It's the right polarity. So let's make sure that it is powering my soldering iron, I suppose. I really need to buy another TS100, just literally, so I can have a backup for this testing that I'm doing with one. Yeah, so there you go. It's heating up it's charging up like it was before. Where's my little temperature thing? I don't think I'm going to see anything in terms of temperature on these things. I think it's just reading 28 degrees, which is nothing. I guess we'll check. This is a disaster, like, isn't... Don't trust this thing. Anyways, well, I guess that's probably Fahrenheit, right? So, oh yeah, I guess it's not a million miles off. 350, 370 that time. Okay, so it's not getting hot, is the takeaway from this, anyways. Okay, so what we have learned is that this IP2721 chip, in this configuration anyways, can power the TS100. The other thing that's kind of interesting about the current draw situation, so we're talking about max current and stuff, how much current can the PCB deliver. That's kind of like a constant current, right? That so I was saying that this flexi friend can take 5 amps, and when I talk about the max that the TS100 takes, so at 20 volts it takes 2.4. that is only for like short amounts of time. While it's heating up, like when it's cold and you're heating it up to temp, like going up to 380, it will use like a lot of power. But when it's at 380, to maintain that 380, it doesn't use anywhere near the same kind of power anymore. Like it just trickles along. I don't know where my USB-C tester is, where I could show you this, but just rest assured that it's somewhere. Not where it's meant to be. I'm pretty sure I saw it somewhere recently and I was like, oh, that doesn't belong there. But anyways. Okay, so I think, unless anybody has any questions, I think we're finished the desk portion of this this journey. No, it's perfectly good. It's a great question to ask, Aaron, and I'll tell you why it is a great question to ask. Because I have the same question about the USB-C thing. So, this is something that I'm not able to use very well, but I want to show you anyways. Screen share plus desk. So this is Eagle. This is SparkFun's USB-C power delivery board, and it works more similar to the one that I was talking about that Great Scott showed, that there's like a button where you can change the values, except I think you change the values over I2C here, and it'll just take, like, so there's a microcontroller built into it and you can program the power modes that you want it to take using I2C. And I was like, okay, one of my biggest problems is, so I showed you here, right? I can have a big fat trace between VCC and VCC here, right? As fat as I want, right? Because there's nothing getting in my way. But the problem with the USB-C is there's VCC. Like, as in, I can't put a big fat trace there because it'll hit into B8 and ground, right? So how do I get enough power from this thing? You know, how do I make my trace big enough that it'll be okay power-wise? So I was like, okay, what do SparkFun do on their power delivery board? Because, you know, they know what they're doing more than I do, I would imagine. And this power delivery board is capable of doing up to 5 amps. And then I was looking at it, and it seems to be a 2-layer board, so I can't really use Eagle, so forgive me. So here's their USB-C V in, so there's 2 V in pins on the USB-C, and they have a small-ish trace between them. Even this is a different size here for some reason. But let's take this fat one here, right? So this is the one on the way out. I seem to be drawing something. I don't want to draw, I want to select it. Select it. Select it. I was able to select it earlier. Why isn't it working now? No. Eagle, help. Stop. You just need one wire to get that much out of it. You just connect one end to the other and you'll have a nice warm heater. I was able to select this earlier on, so I don't know what's going on. Somebody who knows Eagle better. Oh, I'm pressing group or something, am I? I don't want to group, I just want to select info. Inspect. Click the little crosshair right in the middle. Okay, so I got my crosshair right in the middle. right in the middle of which? Of the wire? Oh, the trace. It's locked. I was able to inspect it earlier on. I don't know. I don't know what's going on. Top layer. Oh, maybe I don't have the top layer. Ah, yes. Thank you. Yeah, so here's V in this trace. So if I go to inspector, it has a width of 0.024, right? I assume that's inches, right? Because inches up here too, but also it's the only thing that makes sense. And like 0.024 inches is not a lot. 0.024. I search for it in mil here. Inch in millimeters. So it's 0.6. 0.6, right? Millimeters. And then if you go to this thing and you have current of 5 amps, which this thing's capable of, we'll give them the benefit of the doubt and say that it's on a 2-ounce board. Like it says the required trace width is 1.38, so it's like half the thickness that it needs to be. And then it's the same, so it goes through a via or a via, and on the other side it is a little bit thicker. It's 0.032, but it's still not big enough. That's 812, and again, it's not 1.38, right? So it's still not thick enough, and I was kind of like, what's going on here? And then I was like, oh, but I'm only looking for an optional temp, like the default settings of this page is an optional temperature rise of 10 degrees. There is 2 V-ins, Sven, but the second one doesn't go anywhere. Well, it doesn't go anywhere for this. Yeah, it doesn't go anywhere. So, like, or at least, it doesn't contribute to the current that ends up going to the output, right? Like, as in it goes up here to this V-in, and it also powers the IC, but with a tiny trace, right? And so like the main current is all going through this V-in. Yeah, that it can't take a bigger trace. I was expecting them to use both V buses. Was what I originally thought might happen. Does the manufacturer for the PD chip you have a reference? Is there a reference board? No, there's not. I wish there was a reference board. Yeah, like I guess you could have 2 6mm traces. Like I guess what they're doing though, so say if it is a 2-ounce board, I guess they're just happy for it to get hotter, right? Like, so this is a temperature rise of 30 degrees, which means a 55-degree temperature on the board, I guess, right? If ambient temperature is 25, it rises by 30. You'd imagine that's 55. That should be fine for a PCB as far as I can tell. You can, Lloyd. So the typicals, like if you don't specify, you would get a 1-ounce board, but you can, like 2 ounces is relatively common. Like on JLC, you can change to a 2-ounce board, and it costs $16 extra. if you set the trace width they're using in the tool, you would imagine it would, right? Or I guess it would go the other way around. About maybe if I get rid of the temperature rise and then have a trace width of, what did I say, the 812, so 0.8. Zero. That's just going to infinity. It doesn't seem to let me reverse calculate. But still, right? Maybe I don't even know they're using a 2-ounce board. Like I guess, you know, their design files are available, but telling you what to order isn't, right? I didn't see anything about it. So say they're using a 2-ounce board, like roughly in the right ballpark, that it's getting about 30 degrees hotter given their trace size, and that should be okay. Apparently, like, you know, the PCBs can get hotter than that, and there isn't a big deal. Yeah, like, but 4 ounce is not common for sure. So I don't know. But then the other thing is that I don't need to be as good as that. So they claim to support 5 amps, or this board supports 5 amps. So straight off the bat, I don't need to support that. I only need to support 2.5 roughly. So that's half what they need to support. So let's change that to 2.5. And like, as I was talking about with the current draw thing, like, as the iron is heating up, it will have a large current draw. It'll use almost up to the max. So like, as in, you know, this temperature rise is based on like it getting hot over like a sustained period of usage, right? Like, if, you know, it takes 10 seconds to heat up, like, it'll only have that current for about 10 seconds, and it drops down to like half an amp or something like that. So there isn't really a huge kind of constant draw to it. So I probably don't need to be as worried about like the trace thickness. But I'm still just a little bit unsure what to do. So Geekoid, you can't just beef up the trace width, because you're limited basically to you're limited to fitting it here, right? As in, like, okay, I could make this trace like from here out be really fat, but you know, at some stage it needs to be connect back to this pad, and it can't just be super fat or it'll hit B8 and ground. But the other thing that people have talked about, and you could in theory do, is you have 2 VCC pads. Like, you could connect as fat a trace as you can to both of those and then kind of join them back up again. Now, I guess, like, your problem with that is basically, where do you route it? Current shunt. I think you have the same problem. The problem is, like, the footprint of a USB-C connector just does not allow for yeah, like, so the copper island is fine again in terms of, like, you still have to connect it back to these VCC ones, right? I guess you could do a big copper island out some other way or whatever, but yeah, like, so it doesn't make that big of a difference. So I put in the 3 inches, like 1 inch. It doesn't matter, like, it doesn't change it significantly at all, whether it's 1 or 3. I don't know. I just left it at 3 to be, you know, this board isn't tiny, so like maybe that trace isn't 3 inches, but it's probably 2, right? I don't know. But yeah, like a copper island is possibly the way to go. Like this cheap board has a copper island in it, so could be the way to go. Yeah. Um. So Andy, I don't want to do that. Uh, so that's the idea of like, yeah, you expose copper and you flow solder, and now you've more mass, right? Um, V-bus pads of triple or more. Yeah, but I don't want to do that. I want these to be assemblable by a PCBA place. Now, I guess they will have to do hand soldering for the Ts100, and I guess these shell ones as well. But you know, that's okay. Via on the inside of the VCC and connecting to them to the back would effectively be double the thickness. Yeah, well, at some stage you've other things you need to route out too, like ground. Like, there's no point having super fat VCC pads if you don't do the same for ground. Like, ground has to pass the same amount of current through it, so you need to do the same. Yeah, like the PCB that these guys have made. Where is my mouse? This is islands, right? Let me focus you a little bit more. Sorry. Right, so there's the plus one. You can see that they've got, it's almost like a hole. It's not. It's like a giant via. Is it under? It's underneath the USB connector. Yeah, I'm gonna have a hole, but I won't. It won't be conductive. But yeah, so they do islands, and the just have a huge amount of stitching, on both sides. You can see anywhere you see those little dots are vias between the top and bottom layers. So that's, I believe it's called stitching. And yeah, so that's just shooting as much over to the far side as it can. Might also be used for cooling, but I doubt it. Like, the IC shouldn't be doing anything other than negotiating, right? At some point, there's a limit driven by the USB connector. Yeah, but the limit should be like 5 amps, right? If USB-C power delivery can do 5 amps, then like in theory the connectors should be able to do that too. Like, my laptop charges at 20 volts, 4 amps or whatever it is. So like that USB-C connector can do that. Yeah, so maybe an island is the way to go. Just stitch as much of it as you can at the back here, and then do a large VCC like island down here, I guess. No, I don't think power delivery is an Apple invention. I think power delivery is just a USB standard, I think. Like, there's no way that capacitor is meant to go up there. Yeah, so the other thing as well is I have no idea how best to lay this out. A lot of the pins on the chip are not used. So that's probably a good thing. It also seems weird because I should have a different size. Capacitor for one of them. The 10U cap is 0805. I guess I could only. That seems strange. Could I only find 0805 caps for 10 microfarad? Seems kind of high, but I don't know. So, like, that is the wrong package. So I guess I'll have to swap that out. Yeah, like, I think it should be fairly manageable to route, right? Like, so one of these is probably like the sense path or the select pin, which needs to go high. But like, say, V-bus, that doesn't need to be a particularly thick trace. I'm pretty sure that's just like, you know, the gate of the MOSFET to basically connect VCC to V out. Like, other than that, like, yeah, you have to imagine that this V out, like, maybe I should be rotating the chip as well. Like, it's hard to know. Like, this is the kind of thing that I would normally just like try it one way and see how it works out, and then try it another way and see how it works out. Leaf. When you say source, do you mean like where can you buy the ICs? Is it? I bought it through the PCBA house that I bought it through the PCBA house that I will potentially be using to make them. So I asked them, like, hey, I see this IC and it looks pretty nice, but I can't find it. Can you get me a source of them? And they said, yes, I can. And they'll cost this much. And I said, okay, cool. Can you send me some samples? Well, I paid for the samples, like, but yes, they sent me some samples. So I have some of those IP2721 chips. But they're still in the wrapping. Yeah, so like, is this the way to go with the IC? Like, V out is a long way to go, and so does V bus. So maybe I should just flip it over, but then the CC1 and CC2 are in a bad place. Like, so am I going to make these? Yes. My hope is, hey Dave, how's it going? Q1 is the MOSFET. Do you remember we were on my second channel stream and we were talking about this MOSFET, NMOS, on the power delivery module? That's what Q1 is. Aaron, my hope is to, yes, to make these. Okay, so let's get rid of this VCC. Well, let's turn it 90 degrees and see what happens. I'll get rid of the C1 as well. And this VCC. My hope is to make these and to sell them. I would like to get them assembled by somebody other than me. And yeah. Cool. Can it go on the bottom of the board? I don't want to put anything on the bottom of the board. Nothing. Top layer only. Because I would like to I would like to make it as easy to assemble as possible for the PCBA. Not because I want to be really nice to them, it's because I want to make it cheaper to make, right? So my biggest concern about selling these is the cost of the add-on. Like this cable here, like I think I'll probably need to charge $10 for it, almost minimum, for this cable. Like, as in, I can let people buy them themselves, but like if I am to supply them, and like I don't mind not supplying them, I'll have to charge probably $10 for this cable. That's the flexible one with the XT60 on the end. I'm not 100% sure how much the board will cost. I don't think it'll be that expensive. I need to finalize everything, but yeah. I think I missed something from a moderating point of view. I think this seems to be a much better fit. So whoever suggested turning it this way, I think that was a good suggestion. So thank you. I haven't gotten a chance to watch David's tape video. Looks interesting though. So if I go here, I guess I could just put that up there, V out. Yeah, so the crowd I would probably use for this is Maker Fabs. They're based in China. I've had one delivery of power blockers from them that I have had some issues with, but it's being sorted now. I've been very impressed with their communication throughout stuff, and like that example I gave of saying, hey, I need these things, can you help me source them? And they just did. And I was like, oh wow, this is nice. Like, this opens a new sort of, I guess I could have went to Alibaba or somewhere and bought 1,000 of those chips or whatever, but like, isn't it much easier if they buy them? Yeah, so I will probably just do that. Okay, so I need to change out my my capacitor. My capacitor is wrong. This one. Would it be right in saying, like, I have a 04021 microfarad capacitor and then 0805 10 microfarad capacitor? Like, does that make sense? Like, I guess when I was buying them, I didn't find even a 0603 10 microfarad capacitor. I don't know. So let's get rid of this C2 and we'll bring in, go to the zoomed screen share. It's not a whole lot better. Oops. Okay, so let me go to EELib. I suppose I'm using EU capacitors. And I'm going to 0805. Yeah. I just wanted to make sure I just didn't buy the wrong thing or something. Which, wouldn't put it past me. This is the problem with picking up something that you were working on like months ago. Okay, sorry. I've just placed my new larger capacitor, and let's see, where are we? I suppose I could just move me. Yeah, so that's now as a 0805 capacitor. So I can go up to update PCB. It's up the top. I'm desperately trying to balance having you zoomed in enough and showing you everything. Okay, so I can go to update PCB, and it just is adding C2 and removing C2. Sure, I guess. Okay, cool. Right, so here's my C2, which is now a much beefier boy. So we'll have to move this over a little bit. Man, it looks massive compared to what it was. Yeah, it should probably be alright there. Get rid of this trace. Let me just bring me up here. Yeah. That's roughly what I'm focusing on. And get rid of these traces too, I suppose. I can keep them a little bit separated so they don't get joined when I'm now, why am I doing that? I suppose they have to come in from the side and then go up here. So maybe I'll even keep them more separated. What did I have done here before? So I need to get CC2. Did I just bring it down to the bottom? I don't know. VCC. So I guess we could get rid of what do I have here? This thickness is 0.4. I probably can't make it bigger than that. I'll try 0.45. Yeah, it's clashing. Yeah. So 0.4 seems to be my limit, even now it's given out about stuff. Let me just do design rule check. Doesn't like my clearance. So even 0.4 might be enough. Yes, this iron, this keeps me up at night. So, well, almost. So you can get flexible cable, right? Some people have done basically the same thing, but with like silicone wire from a tattoo gun. But I'm worried that it makes it more complicated because somebody at some stage needs to put a 2.5 millimeter barrel jack on it, and like I'm just wondering if like having this is just a nicer finish to the whole thing in terms of, you know, that's it done, that like, you know, like it's a finished product. If you don't want to buy it from me, you can buy it yourself. There's some people who already have them. If you burn a hole through it, you can just buy a new one. So, but it does like this does increase the price. But yeah, I don't know. I don't know. I guess it would be possible to just make one that just has, you know, regular solder pads here. You know, rather than the XT60, like it won't change anything this side of the PCB. So yeah, could do that. Somebody suggested to turn R2 around and push it up a bit. Yeah, I suppose, right? I could do something kind of dumb like that. Makes it a little bit easier to wire. But I'm so... I don't know if I'll keep all these labels like this. They seem massive compared to other things as well, so we'll see. Yeah, so that's all the components laid out. So do you just start routing and see where you end up? Like, I guess... But you see, I still have my clearance issues, right? So like this clearance issue is like between the pad, like this hole in the ground pad. Like I can't do anything about that there. I guess I just need to change my I guess I just need to change the rules, right? Where is that design rule? Clearance. I guess I just need to make it smaller. Right? But I don't even know what I'm changing it to. I guess I should probably look up what they do. If Xeon is still there, can you tell me what's a valid clearance I should have here? Let's change it to 0.1 for now. Setting. Well, hey, I suddenly have no problems anymore. Everything's great. Right, like I guess probably the first thing I should sort out is VCC. Like, would it be nuts to bring VCC down here on an island? Just a clearance between a trace and a hole, Cian. Like, say, between this hole and this trace, or this hole and this pad. Like, I'm after changing my design rule to be a clearance of 0.1, and now it's happy enough. Is that valid? Yeah. I think Cian would be intimately, like, familiar with... Yeah, like, the only thing about keeping the first part of it narrow is in that would still... Like, I guess it's a bit better because, like, it's shorter. Yeah, well, maybe. Like, I could just make that... Well, like, see, at this stage I could just make it be a copper fill, right? It's 2 layers, yeah. I don't want to go any net. I want it to be VCC. Okay. Would it be nuts to bring this out at the bottom? It is a hole. It's a hole, not a via. Oh, but I will be using the other pins. Yeah, maybe I should start with the simple ones, right? So I'll go to... Start at 0.254. Go up. I don't know why I wanted this one first, but anyways, it's fine. Ugh, that ugly trace. I'll get back to it in a minute, I promise. I'm never gonna get back to it. Okay. Jeez. It's actually been months since I routed a PCB. But anyways. Let's just get rid of whatever this is. Let's keep these nearby each other. 0.13. Okay. Yeah, I just literally jumped the... Seems to be happy enough with that anyways. Oh, I still have clearance issues. Between what? VCC and the whole... So it's still not happy with that. Yeah. We'll get back to it in a few minutes. Okay, so... I guess I could just put this down a little bit. The other thing as well is I probably want to add holes for like a case or something. That little island is not going to do anything. Yeah, like I just started to play around with it. Like I guess I have to route that somewhere. Like, do I go out the front with it or do I go down and around with it? Like, as in, at some stage, I need to. Yeah. So I guess I could just keep this up here for now. Shell. Okay, so I need to connect all my shell. Well, I'll do, yeah, I can do that on the ground. Do they need to have a large current in them? I will. Does my. Let's go back to my sheet here. My shell is not connected, so let's connect these up. This is not a very pretty schematic, but all right. Update PCB. To the side of the USB and route them out from inside. If you move your C1 to the side of the USB and route them. Okay, yeah, that does make sense. Yeah, because they're the only things that really need to come out the middle other than ground and VCC. Let's just throw them up there. Ugh. Let me just select this and delete it. I guess I won't be as near the holes anymore either. So let's try 0.5, see if we can get away with that. Straighten up those traces afterwards. Alright, so that leaves me, yeah, the resistors, yep. Yeah, the only thing about that one is it doesn't have this, and I'm gonna add that. It also has more stuff, and I don't know what that's about. Yeah, my footprint calls them CC1 and CC2. Let's just connect the shell. I guess I could probably do that as an island or something, but make that the side of your island. Yeah. That can be the side of my island. Probably makes sense that way. I guess I have the same problem with ground. Right, what am I going to do with ground? I need to bring him out and stitch it to the other side. If no data is needed on these, can I add LCSC? LCSC. Yeah, I don't need data. This one has way less pads. Seems to be similar in terms of like the physical strength of it. So what would be the downsides of using something like this? I would need to see what pins it has. B1, 2. Does this break out the CC pins? Copy file for ground as well. I don't know what you mean by copy fill. Okay. Okay, so that's what I'll do is I'll just make a clone of this one, and I will possibly replace it at some stage, but I'll swap out the USB-C for this guy. Okay, so I'm going to libraries, do my search. Just place this. So this doesn't have, does it have CC pins though? I guess B5 is the, yeah, I have a B5 and I have an A5. Okay. Okay, so let's get rid of this. So you know what, I'll copy this across down here. So that's on A5. Let's put that there. We have a problem though. Which one is A bus or which one is V bus? A5 is what are all these zeros? Like like are they the shell? So let's go back to this one here. Oh, it's here. It's just sidewards. Thank you, Alex. Appreciate it. So B12 and A12 are my ground. I guess. And then my VCC. That's not right. Oops. Okay. Used to buy 100 cables of which, Alan? A crossing like this. I guess I could just bring it up here. There's no reason why I couldn't connect them to each other, but Alan, you've 300 Node MCUs sitting in a box? Did you used to teach or something? That's a lot of Node MCUs. Okay, so let's try this out, because there's no point having this if we don't need it, and we'll copy this into its place. So let's update PCB. Keep that, yeah. Look at this bad boy. Look how fat of pipes we're going to be able to put in this yoke. Do I need to overhang the... This one has it overhung. I need to find the middle of my PCB again. I guess it's roughly around there, but I need to actually find it. Should talk to the guy with the Swiss accent. What would I talk to Andres about? I'd love to talk to Andres. I don't think he'd have anything to talk to me about, though. Oh, look at all this room for activities. We will be able to put the biggest, fattest traces in here now. Yeah, I've been following Andres for a long time. He was a big inspiration. He was a big inspiration for me setting up my channel, to be honest. But yeah, I'm not sure what he'd want to talk to me about. I think basically anything I can do, he can do better, and I know that's a song, but maybe with the exception of like APIs, hitting APIs or something, but like it's a pretty small subset of the stuff we do. Okay, I guess there isn't much point doing all this tracing until I get that measurement right, where the center line is. Unfortunately do not have a document of it. I don't know if this is the right way to do it on easy EDA. Maybe there is a better way of getting the center line, but I like literally just take the measurement and then do a document layer that is of half that. So 7.74. So that's my halfway point. I'm going to zoom out a lot here. I can just hide the document when I don't need it, but so I actually had it spot on. Oh, nodes, okay. Yes. What do you want to do, Diego? So like, if you follow Sion's channel, he's made his tiny picos, and like he would never have been able to do that on easy EDA, I'm pretty certain, or at least it would be very challenging. But like I have done a decent amount of stuff with it, and hasn't been a major problem. I might be tight for room here, Alex. I don't know with my MOSFET. I guess I'm not too bad. I just don't need this part of it. So Diego, I first started looking at PCBs. I tried KiCad, so that was the first thing I used, and I found it quite hard to use, and I didn't really spend a huge amount of time on it, but I didn't find it too easy to use. And then the second time I tried to make a PCB, I used Eagle. I found it better. I'm pretty sure I did annoy Sion like quite a lot during that time of just like, hey, how do you do this? Hey, how do you do this? How do you do this? And I made my power blocker using it, and then I tried out easy EDA, and I found it much easier. I think it's more approachable than the other two. Even just simple stuff like, say you want a USB connector or whatever, like or even just like, say you just want an 8-pin standard like header connector. Like I found that really weird in Eagle to be like, oh, you have to go into the SparkFun library to go get that, and it's like, what? Like, and even like the searching is like searching in an old database with like percentage signs or stars or something. Like I think easy EDA's like integration of like libraries is much better, and then there's also user contributed stuff, which is kind of both a blessing and a curse, because some of the user contributed stuff is not good. So like if they do warn you now if you're using a user contributed thing, saying like, hey, this is, this could be crap, basically. I'm doing a press to simple this thing. I'll keep. Yeah, no, easy EDA is, if you just want to make something simple, easy EDA is like perfect. Yeah, why not? And like it integrates nicely with stuff. Yeah, I have made some components for EZEDA, but very few. I think I would find it much easier to move to Eagle or KiCad now than when I was starting out because I'm more familiar with layers and trace widths and blah 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 blah, and I don't think I'd find it as challenging. So I wouldn't be too worried about stuff. Yeah, never trust the footprints of the user contributed stuff. Yeah, I agree with what Johnny said. The concepts are the same. Okay, so a big fat VCC pipe. So what am I doing with ground? Am I doing ground on the bottom layer? Maybe? I got my fat VCC pipe. I guess if I... It's a bit weird looking. Look how big of traces I can make. 0. I especially don't trust my own footprints. Oh crap. I was like, why is this white? It's white because I'm doing the wrong thing. Right, that can be the start of my big fat pipe. VCC, I suppose. I haven't actually used this before, so we'll see what this is like. Take me home there. Is that ugly? It's pretty ugly. But I guess I could like smooth the corners, might make it look a little bit nicer than that. It's pretty ugly. Yeah, will I smooth the corners? Like, or kind of cut them? Yeah, it's pretty ugly looking. But maybe ugly is okay. I guess this, yeah, that's probably alright there. You know what, it's fine. Let's leave it as this for the moment. V out. I guess somewhere close to the edge. Do. After making some form of a feck up here, but it's fine. Look at that. It's beautiful. Cut the inner corners. They do 90 degrees so well. Oh, look at that. That's terrible. Can I just edit that point? No, don't do that. No. Let's just undo anything I've touched here. Yeah. Cool. Go. Rebuild. Rebuild the copper area. Yeah, look at that. It's beautiful. Except this isn't beautiful. What can I do with this? I suppose I could just bring it up one higher. Then bring... No. No. Come back. Yep, there we go. Rebuild copper area. It's a lot bigger than the other one though. So I guess I could just bring this up. Bring this out. Do. The electrons won't be able to ride their way around that one. I need to lock this part, so I keep selecting the the thing, what's it called? The XT60 connector. Okay, so let's fix up this. We go for nice roundy parts. Do you know what? I'll just start this one again. To make it look all pretty. VCC. Capacitor. Is that how I pronounce it? Yeah. So that would be an advantage to Eagle for sure. Score 1 for Eagle Town. And you know what? Maybe it is possible to do in this. I just don't know how. That is a very, very likely scenario. Hey, where are you going now? For some reason, all I can think of when I'm thinking about Eagle at the moment is JD from Scrubs going, Eagle! I don't even know what that's from in Scrubs or anything, but it is stuck in my head. There, look at that. That's beautiful. Except what happened here? I'm also planning on having a big cutout here, right, for mounting a case. That will be a problem. I guess I could just put it here. Let's worry about the case afterwards. What happened to you? Let's get that there like that. Straighten you out here. And bring you down here. Then we will rebuild you. We have the technology. What did I pay for the IP721? I think it was like 60 cents a chip. I could be wrong. I paid... What did I pay for them? Um, 80 cents a piece. That's in quantities of like 1. So I guess it'd be cheaper in slightly larger quantities. Contact Maker Fabs if you can't find a source for them. That's for 1, yeah. So I bought 3 or 4 of them off them. I thought I bought 3, but there's 4 in this pack, so I don't know. Yeah, so there's my big fat trace. So I'm gonna have to do what? Ground. What do I want to do here now? Because I need ground to be just as big and fat. I guess I can put it on the... I can go back and I can go to the back and... Or do you know what? Maybe, like, do we even need to? I have so much room now. Like, I can put in a really big trace here, but I don't know. Not sure. Look, what did we use here? 0.8. So I would need to go to the back. The back. Let's go here. Up. And do that. And then I guess would you just like via the shit out of it? But if you via underneath the USB connector, is there a potential problem of it shorting? Like, I don't see where either... Well, this one is... Xeon is about to go postal. Why is Xeon about to go postal? If I do vias here, right, will it connect? Well, the one I was using before was a recommendation from Xeon. Yeah. Yeah, I don't trust that they will be good. So I guess I could just move VCC further out. It really doesn't need to be this fat either. Sean. Oops, bring that one back. What am I doing? Oh. Like, why don't I just do a fatter trace, right? 1.6. And we'll start it from here. That is not a 1.6 millimeter trace. You liar. There, look how fat of a trace that is now. Again, why aren't you... I've selected 1.6 and then it's not doing 1.6. There. The fat boy can go out here. It's not letting me connect back, but that's fine. Look at this. This is hideous. It's hideous. Isosceles triangle. That's true. Put a nice little triangle there. Yeah, I'm happy enough for ground to go to the bottom. Let's do that. 0.8. So I'll just tint the shit out of this. Let's get rid of this back one, because I don't think that's any advantage to us. Not a pad. Via. Huh, I was kind of expecting to be able to fit more vias than this. I'm not allowed to have them overlapping each other like that. Ugh, what are you doing? Stop. Okay. Does it have a problem with something? Design rule. No, that's not what I want to check. Sorry. Design manager. Via diameter. Design rule check is. Ugh. The shield isn't technically ground. Can you tent vias an easy idea? I don't know. To answer that question, what do I want to do here? Oh yeah, my design. Fuck it. Design rule check my via diameter. It doesn't like when you're working in mills. There, look how beautiful that is. They seem really big. I guess I'm just super zoomed in or something, but they seem really, really big. Why can't I see them now? Now I'm ready to go on my big fat pipe adventure. I guess I could just copper area it, right? Hey, yeah, sir. Did you miss much? We just tested a breakout board of a chip called an IP2721 that it could power my soldering iron, and it can. I'm just gonna connect this up and then make it fat. And then after we did that, oh, now we're just laying out. Now we're just laying out a PCB to have all of those things in one. I'll probably just make that as fat as the other one too. What did I do? 1.2, I think. Cool, look how fat it is. Okay. So that gives me that. Let's do the same with ECC, I suppose. Doesn't look to be 1.2. It's because it isn't. Probably enough room there for a hole. Or two here. Just want to keep them separated because I remember seeing Arturo post a Twitter link about like if you've pads too close to each other, sometimes they join together in the I don't know, the assembly process. So I need to get ground out here. Well, I guess I can just bring ground down there. It's not a problem, really, right? 0.254. I guess why wouldn't I move that capacitor? It's in a stupid position at the moment. I could definitely move that more in here. I normally use Easy EDA, or at least I do for the moment. I do, like, I would never go to like BAT for Easy EDA. I guess I could center this and like I would never be like, oh, everybody should definitely use Easy EDA because it's the best. I just think it's fine. I'm happy enough to use it. I find it a bit easier to use than the other ones. But I would fully understand other people not wanting to use it. Why do I want to do this? It's pretty hideous, but sure, look, it works. I'm like, I don't know if I would take anything from me, like from a PCB designing point of view. Like, I guess I know more than some people, so maybe some people could learn stuff off me, but I would never claim to be good at PCBs, or at least in comparison to other people. But then you'll get people saying, oh, that's imposter syndrome. I just don't think it's something I'm particularly good at. Like, it's fine. as I completely mess up this thing. What did I do there? It was impressive. Doesn't like my doesn't like my fat traps. Well, I have to center this, right? Everything else is centered. Would be crazy to not center down. Yeah, look, I'm happy enough with what I got. I don't know how big I actually need to make this, but I'll just do that. VCC, can I sneak it out here? I can, yeah. Very good. I need to get ground down to here, VCC up to here, but I suppose I can just bring VCC up this way, right? No harm. Does me alright. Ground, I'll bring it out from here. Right, so I guess I can bring CC1 and CC2. See you, Diego. Thank you, David. Yeah, do you know what? I think it's starting to come together. I'm going to give MVP of this stream to Alex for suggesting I change the USB-C footprint. Should I leave it overhang a little bit like that? Most people seem to do it. Maybe even a little bit more than I have it overhung, but yeah, I'll leave it a little bit overhung. The only thing about it being overhung like that is, will it be able to be PCB-A'd? The answer to that question is yes, because some of it needs to be hand assembled. So that's fine. I think this looks weird, but it's fine. I probably will replace this ground with a fat ground. 0.4. That's true, it'd make the 3D printed case a little bit nicer if I have a little bit of space. I think you're right, David. What do I want to do here? That ground needs to be fixed up. I guess if I get ground from here rather than here, I'm still gonna have I have to get to CC1 at some stage. Could make it sidewards. I'm just trying to think how to route to CC1. Yeah, I think I will add a ground. Yeah, I suppose I could do the entire bottom in ground, right? I currently don't have anything there. Yeah, I think that makes sense. I'll probably do that. Yeah, so the thing in the neighboring panel will be this, Alex. That's not even a lot of overhang. I wonder, should I make it bigger? Will be this, but that has to be hand placed because it's a true hole component. So, like, it can't be reflowed. So I think it should be fine. Yeah, I think I will add a ground pour. And I'll probably make VCC fatter. Okay, so CC1 and CC2. So let's just... Which is the easier one? CC2 is by far the easier one. Yeah, I hate when it does that. Again, why would you do that to me? Why, easy EDA? Why? Let's try one more time. That's better. Now, CC1. I'll probably tuck it in a little bit closer. I could pull ground up using a via or something. If I'm doing a ground pour. Oh, you. Why? Stop selecting the entire thing. I don't want to select the entire thing. I just want a part of it. Easy EDA, you're letting me down. Normally you can just touch it or double click it. Ah, here we go. I don't know what I did different there, but let's just delete from there. And maybe I can't delete just that end a little bit. Yeah. Looks delightful. Do you need to put any mounting? Yes, I do. And you're probably right, I'm kind of eating into my mounting hole place, so I should probably even tuck this back down a bit. So I bring it around here, a little bit more than that, I suppose. Bring it around here, and if I tuck it back down here, nope. Leaves me room to have the mountain hole like up here somewhere. Yeah. I don't know. Yeah, I guess if I move that VCC doesn't need to be that close here. I aim to have the mounting holes around here. Yep, easy EDA lets you just export the Gerbers. So like I've ordered boards from from who have I ordered boards from? PCBWay, Osh Park, or JLC, from Easy EDA. So there we go. Look at that, super neat. Sort of bit of room for a mounting hole here. Not sure if my mounting hole will be big enough. I'm happy enough with the mounting hole on the Flexi Friend that I have. I've never used dirty PCBs, or Diptrace, another one. CC1 and CC2 might be control length. I haven't seen anything about that, but maybe they are. I'll have to check. Right, my holes are... The holes I was using are too big. I could make it work. Same down here. I could get VCC to tuck in. It's a little bit off balance because the weight would really be up this end of it, but I guess it doesn't really matter for a case. Times a 12. Perfect time to be ripping stuff up and starting again. Yeah, sure, let's put a hole down here. And see if we can work around it. Even my ground. Well, I'm not too worried about the ground because I am going to fill that. I can probably drag this down here. Drag this down here. Probably sneak out here. Ugh, so close. Do I have any room up? Not according to this. Right, what was the question? It was about CCR. You see, it's not... VCC doesn't make it... Yeah, I guess there's no reason why I can't put VCC at the back here. Like the connection between the two. Does that gain me anything? Means I don't have this ugly looking CC1. Just move him up one. Probably be alright. Move him down one. Have to fix him. Yeah, I guess there is no reason to not do like a copper fill of VCC, right? On the bottom. Hey Graham, how's it going? Okay, so what are we gonna do now? Let's get rid of ground. And we'll do a big ground copper fill. I'm going to copper fill everything. This is really hard to see. No, I'm not happy with that. Go back. Why was that so hard to see? Ground. Okay, well, starting outside. Bringing it all the way to just before the shell. Bring it down to beside the shell. I really wish I had hidden my toppler. No, because I can't see shit. Let's see how this ends up, I suppose. I have a feeling this is going to be hideous by the time we finish. Let's find out. What is going on here? Oh, it's keeping itself away from. Well, other than this part, I don't know what's going on here. I think that might have been the right spot for that. Keep this flat like that. Grab it and rebuild. You're finished. You're faster than me, Mark. If I want to keep this symmetrical, I need to move this up. This up. Even higher. build copper. I guess this needs to be, no. You, no. You, up one. Does that look alright? Yeah, it looks about right. That looks about right. Okay. So there's our copper fill on the bottom. We need to get ground into position. Put a nice chunky via here. What are you, via? You're nothing. You're nothing. So I'm just making that have a net of ground. Suppose I can do the same this one. Okay. Let's put our one here, our two there. I guess we'll do one for shell as well. You know what, I don't know if I need to be as neat with it. I think I can just be like here. Oh, I'm doing it on Toppler. I think I can just be like here. Here is roughly where I want you to put this copper. Figure out whatever you gotta figure out to make it happen. I'm on the Toppler again. How did I do this? Yes, let's basically keep it tight to there. There's out its copper from there. Oh, OBS kicked off or something. That seems to be alright now anyways. And there's shell. Happy enough. Space, click and drag. You can middle click to move around, but that can be a problem too. Okay, so that's gotten me that. I need a big fat trace to connect this guy. So let's do that, I suppose. Let's make it like 2 millimeters. It's a big monster trace. Okay, V out needs to be connected up there. It's not a problem. Doesn't need to be a big monster. Trace, this one, I guess it could just be like 0.4, I think I've been using for the power traces to the IC. Let's get rid of this fat trace. VCC. I haven't really made connecting up CC1 and CC2 any easier, but let's see how I get on here now. So I'm gonna start here, go down. I suppose I could nearly just do like the entire top of the board, or this entire half of the top of the board in VCC. There wouldn't be any harm in that. Right. That is... I seem to have islands here. I don't really need them. It says keep island, no. See ya, Alex. Thanks for joining. Yeah, it seems like it's just heading off in all sorts of weird directions. I wonder, should I not allow it to do that? Like, what is the point of VCC going up here? I would say there is none. Even kind of going back here. Well, I suppose they could be better connected if it wasn't for CC1 and CC2. I guess I could just tidy up the fill so it's only doing the front. Yeah. Oops. My copper fill area has grown legs here. I might just delete it and start again. Alright, so I want to start here. Go as far as here. As far as here. Got my fat trace. have this piece of copper down here that's really doing nothing, but should be okay. I guess my biggest concern is there's not a huge gap there. Could move the IC a tiny bit. That would get us a little bit more. So have to fix all these things that are bumping into each other. I think the main problem is the copper area at the bottom. No, it's not. Let's redo that trace. 0.4. Alright, and the rest of them seem to be okay. And then we will... Two. 1, 2, 1, 2, 1, 2. Copper. It's a bit fatter. What's going on here? I have a slightly slanty back. Not that it makes a huge difference, but I think I do anyways. Seems to be slanty the other way now. Be alright. Okay, so let's take a look at the photo view of this. So we've got a big fat trace between VCC and the power pins. That seems alright to me. Then ground is a viad to the other side, where we have a big copper fill, and we've the shields all connected to each other with a different copper fill. Seems like a small enough gap between them, but I guess it doesn't really matter. Okay, so I think we're probably at a point where we can start tidying up the thing. This is, I guess the whole bottom is possible for me to put my writing on it and stuff, but I'm gonna get rid of USB 2 because I don't think that's any point. Like, would you keep Q1? Like, I don't think so, right? It's not a kit. Ground bigger on the connector. Which connector, David? This one here, is it? It's a full copper fill on the back. Maybe it's not big enough on the... Which, here, is it? I could see if I can make this bigger. Well, I kind of wanted to make that bigger too. Might be able to get away with making that bigger. I'll probably won't be able to. We'll see what it's like. I think it'll be okay. Yeah, I think it'll be okay. Have ground on that. Possibly don't need it to be a wire here, but it doesn't really matter. Okay, so U1, I am going to get rid of display name. If it'll fit underneath it, it doesn't. Make it a little bit smaller though. Yeah, it fits in it. Fits. Yeah, like I don't think I need to have like C1 and C2. Do I? I don't think so. Right. Like the two resistors on the board are the same value, so you can't mix them up. The capacitors are two different sizes, like physically, so kind of hard to mix them up too. And the MOSFET should be alright. And the other thing with this MOSFET is as well that like if I find out that I've done the MOSFET wrong, like I can test the circuit without the MOSFET by just bridging these two pads. So it should be okay. Yeah, I'm going to get rid of all the prefixes. They can go burn in hell. Right, so I'm not going to be able to fit any text on the top of the board, so I'm going to have to go to the bottom of the board for my shits and giggles. Let's get rid of that, and let's get rid of that. Yeah, I have loads of room for activity here. Do I want to call it the... What did Dustin Watts call it? He called it Flex C friend. It's a bit of a stretch. I think I'll just call it the Type C Flexi friend. Flexi friend C. I'll probably change the name of this at some stage anyways, but Flex C friend. That is pretty good. Will we go with that for now? Shit, this is on the bottom so clear, please. So Flex C friend. Weird flex, but okay. Flex C friend. Wired. I'll take my little Brian lock on YouTube and my website. Throw the Brian lock part down here. I do not have this page created on my website yet, but I'm sure I'll create it at some stage. FFC, or oh, I guess it'd be Flex C friend, right? I don't get the wire. I love the wired Wired flex, but okay. I do like the name, David. I actually love that. A well-used weird flex, but okay, is brilliant. Flexi friend C. Maybe I'll just call it flex. Flexi friend. Is that a stretch? Like, flexi friend? Like, that's what these things are called. But nobody knows what these things are. So, I don't know. Could also go across this way. Fits pretty well. What do you think, guys? We go. Make this even a little bit bigger. Height. 5. 1.5 does not fit. I think 1.3 was probably the best bet. Where else could you use this? I think this is really specific for TS100. Like, really specific. But that makes me think, though. That makes me think. So this pin here, cell, is the select pin. So if I wanted to FCF, probably should be, right? FCF. FCF. We can change this at any time. If I wanted to like disconnect those, I'd have to cut the trace, but it's under the pad. Makes it quite difficult to cut the trace. I guess I could bring it around here, right? And then I could cut the trace, but I don't ever want to use it. So, Jet, Gyrotech, you were asking where else could you use this? This is super specific to this application. Like, the XT60 connector on the end taking 20 volts, I think that's super unusual. A solder jumper, yeah, I would just have to bring it out somewhere that's not under the chip. But like, the default state I want it to be is 20 volts. So I think for this version, I'm just going to leave it always connected. Sure, look, I can make up another one where I cut that if I wanted to. Like, I think this is super specific to the TS100. Is Flexi friend? Am I going to get sued? Flexi friend. I don't think so. I think it'll be fine. Nothing too obvious popped up. Okay, so I just need to put a version number on it. Excuse me. Which I'll just copy and paste from the other things, because that's what I always do. I suppose I should probably put TS100 on it as well, right? TS100 Flexi friend. Do I put a dash in the TS100? I didn't know. Yeah, I like what that would do is give you the ability to make it not 20 volts. It would give you the ability to make it 15 and make it 5. But as far as I know, and I'll need to test this, um, if your power supply is not capable of doing 20, it will negotiate. Um, it will negotiate like 15. It'll take the next highest one. So let me go to screen share plus this. The select pin is used to configure the maximum voltage allowed by the IP2721. When cell is pulled high, the IP721 will request the maximum voltage of 20 volts. When cell pin floats, it'll take 15, and when cell is connected to ground, it'll take 5 volts. When the maximum voltage supported by the source terminal is less than the maximum voltage supported by the IP2721, the IP2721 will request the maximum voltage supported by the source terminal. So that to me means, like, if my power supply is only capable of doing 15 volts, my chip will take 15 volts. So, like, I don't see any scenario where for the TS100 you don't want whatever the most the power supply will give you. So I don't think I need to make that kind of flexible. We already got the flexi friend, so I just need to put a version number on it, and away we go, really, right? Like, you know, it's tempting for me to put a jumper on it, and then it's like, oh, if I have like a jumper, then, you know, I can do whatever with it at any stage. But it's just kind of like, I can't see a scenario where that would make sense, and it just makes some things like, if you have a soldered jumper there and you need it to be high, that would mean that it's another assembly step for the PCBA crowd to like assemble this for you, in terms of they have to solder that jumper, which isn't a big deal. Like, it's probably going to cost you a couple of cents, but it's something to go wrong in the assembly process as well. So I think we're done. Oh, look at us, it's populating some ICs. Yeah, like, I don't see any other use case for this other than a TS100. I could be wrong, but I just don't see it. I should probably put something up the top in terms of text, should I? The top possibly won't be that visible if you put the heat shrink on it. Like, you can read what's on the bottom with the heat shrink, but like, there is some text there and it's hard to read. Like, flexi friend and TS100 is there, so I guess I should add plus and minus down the bottom as well if I don't have it, and I don't. So let's do that. I find going into photo view mode quite useful, because it gives you a kind of a better like feeling of the size of the thing. Maybe I should put like USB-C power delivery here. Uh, that's the plan, Aaron. Yeah. So, like oh, sorry, I'm not sharing my screen. Yeah. So that's the plan. The crowd I mentioned earlier, Maker Fabs, they have, they were the people who sourced this cable for me, which you can't see anymore. So like I originally had one of these cables myself, and I bought it from AliExpress. And like when I was ordering stuff from them, I asked them, "Hey, can you find me a source of these right-angled XT60 connectors? Can you find me a source of these IP2721s? And can you find me a source of these cables? But I really need you to find the one that has the orange box, because I'm pretty sure you can buy not orange boxed ones, and they're not as good." And they were like, "Yeah, sure, I can do all that stuff," and they sent it on. So my plan would be to, so I'll order these off JLC and try assemble one myself, and if that works out, I will then ask for a quote off them to make some up for me, and I would order some of these cables with it too. So the idea would be that people could buy everything from me. Um, I don't know, like, without knowing the costs of stuff in terms of how much they'll charge for assembly. Like, my feeling would be that this could be around $20 plus shipping. Shipping wouldn't be expensive. It would be like $4 or $5. Um, but like the other possibility as well is that they see you, Johnny, thanks for joining. The other possibility as well is like seeing if they can drop ship it, as well as me getting some to Europe, and reselling them, or like reselling them through their mine, selling them directly, get them to drop ship it. So that would save on like the postage cost of it coming to me and then me shipping it somewhere else. But like shipping from China is so disastrous at the moment. Like so, like my power blockers got shipped in like the start of March, and they just went missing. Basically, they didn't go missing. They just got stuck in customs. They just never left China. Um, and then they, in the end, like, Maker Fabs got the package back from the shipping company and then DHL'd them. Like, I paid for DHL, but like, you know, as in, it kind of put me off the idea of the drop shipping, that like just stuff is going missing basically. So I suppose I should probably put USB-C USB-C, is that the right way? Yep. Power delivery. Supposed to do power delivery 20 volts, 20 V, oops, 20 V. Get rid of this minus sign. I don't think I'll get into selling the power bricks. I just don't think I can make that like financially reasonable. Where are you based, Aaron? In the US? Like, I'll be able to, basically like a Mac charger will work great for this. The power banks, I guess, are a little bit different because, you know, UK. Okay, so if you're in the UK, I can give recommendations of stuff to buy from Amazon because I also buy from the UK. Like for example, the power bank. Like I would never be able to sell these power banks for cheaper than Amazon can. I wouldn't even be able to buy them cheaper. Like I can't even get these shipped directly to me. But say for example, if we take a look at, let me go to private in case I reveal something about myself. On Amazon, Ravpower bank. Yeah, so you see, I'm pretty sure I paid less than this for it, but so see this one here. This is the one I have, the Ravpower. I'm certain I paid less than this for it. Ravpower portable charger. See this 60 watts power delivery. So that's like how I knew I could. Like that's the rating that you want from it. So like said, this one here, it also does power delivery. One of my kids is up. But it can only do 18 watts. You really want a 45 watt one is probably okay, but a 60 watt one is there is no way, Brian. What's the no way, David? So how I have to get these shipped to me is our postal service, like your equivalent of Royal Mail, has there is no way I paid 42 for that. I probably paid like 30, but I didn't pay 42. I'm a cheap person. I love a bargain. Let's see, how much did I pay for it? Search Ravpower. I paid. View order details. So I bought it on the 10th of February and I paid $29.39 for it. It was 42. It was 42, but there was like £15 off. No, that's ready to go, Michael. Like that's just. I actually really like this because I can charge my MacBook from it, like which is nuts to me. Like I said, oh my laptop's running low. Can plug my power bank into it. A 45 watt is pretty much on the money for what you need. So if we do our calculations again, so 20 volts divided by 8.5. That's so 20 volts is the power delivery, 8.5 is the ohms that's in the resistance of your Ts100 tip. So that's 2.35. So if we multiply that by 20, like 45 watts is basically there. Like, and as I mentioned as well, so if you were following that, I calculated how much current it uses, and then the equation to get power is P is equal to IV, which is current by voltage. So 47 watts is how much it would want. But like as I was saying all along, that's not a constant thing. So like once it's heated up, it won't need that. So yeah, I'll give you the link. I won't even affiliate link it. I like it though. Feels like nice quality. But yeah, so how I have to get it is like the equivalent of Royal Mail have like a warehouse in the UK that you can send stuff to, and they'll bring it to your local post office and you can go in and collect it. Now it costs like a few pounds, but it's fine. It's basically the only way I can buy power banks because they won't ship batteries to me overseas. But yeah. Okay, so I think that could be us. Power delivery 20 volts. I'm really happy with it. It took way longer than I probably should have, especially seeing as I had all the parts already. Um, but yeah, this is great. I'll order this tomorrow. Is it $36.99? I've lost my Amazon thing. Yeah, it's 40. Which did you search for? Ravpower USB-C dual input. I'm gonna search for that. No, it's not that one. It's not that one. It's this one. See with the green. See with the green one. So it's like the fifth result for me. Yeah, this one. Yeah, it's the one I linked to, anyways. Yeah, that's the exact one I have. You'd probably need a cable as well, though. I'm pretty sure the one that comes with it is pretty short. Yeah, work away. Do post the link. I'd actually really like to find a power bank that can only do 15 volts as well, and see like what happens. Or maybe one that can only, yeah, like the 45 watt one. The 45 watt one I'd be interested in too. To see. Yeah, that's really reasonable in price, isn't it? Yeah, like 45 watts from that is nuts. Like, that's great. You'll have to be a beta tester, Colin. Okay, yeah, I think we're good to go here. I'll rename this Flexi Friend. Flexi Friend. And rename this. Oh, did I clone that one? Oops. What if I v1.0 flex c friend. Yeah, I'll order that tomorrow. Hopefully we'll get it pretty soon. Right, Mark, thanks for joining. Yeah, I think the cheaper USB cables are up for the job. Yes, I think so. Like, I would basically get anything like Mac USB-C adapter. No. Power. Am I looking in the wrong place? So I got one of these recently. I think it was this one. So this was, yeah, I'm pretty certain it was this one. Hey, Bitloony. Oh, don't worry, I just designed the product that's gonna take you down. Look at how beautiful it is, Bitloony. And it has such a great name as well. Look at those two components. Look at this Ts100 Flexi Friend. Rhinelock. Yeah, so we think we have, why not use a PSU? Why would I when I can use USB-C and a power bank, bit loony. A power bank. So I truly have a portable soldering iron. Yes, that one says currently unavailable. But yeah, I bought one of those power supplies and it's not fused, so that's not right. But other than that, it seems fine, and the cable that came with it seems fine as well. But this is actually really valuable information to me. This is really valuable information to me, Aaron, because like these are the type of questions people will have. So it would be good to have answers to these questions. I can't see myself being in a position to sell the power supplies as well. I don't think it'll make sense. But yeah, it'd be good to have kind of like, this is the type of a power supply you would need, you know. It speaks to me. I used that with the power bank. I got $7.69. What? Oh, mine was like £30 or something. Yeah, that's the other thing. Like power supplies get you in trouble. Yeah, Aldi have a chainsaw coming in on Thursday. Aldi have a chainsaw coming in on Thursday, battery powered ones. We have reserved like an electric or a cordless lawnmower and strimmers. So we've a big garden, but we're gonna have a robot. Do I want to add an LED? Do I want to add an LED? Yeah, the Ferrix ones. Yeah, they're very cheap. Very cheap. Like the 40-volt battery is €35 or £30, which is relatively expensive. But nearly all those, this forest definitely does. Nearly all those, like say, lawnmowers, the cordless lawnmowers, take two 20-volt batteries. So yeah. But the thing is, like, some of the tools are so cheap. Like the strimmers on its own is €25. Like, no, you need the battery. Yeah, I have had decent luck with Aldi stuff. The 3-year warranty as well. Aldi and Little stuff. The 3-year warranty is great too. They're normally fairly no quibble or whatever. But I have the cordless lawnmower and strimmers reserved in Argos, so we were like, will we get the, because Aldi have a lawnmower coming in too. And it's kind of like, then we were like, sure, Aldi will be a war zone on Thursday. So we were just like, oh, we'll just go to Argos and get these ones. So we have a couple of work stuff already, so it'll be handy to have more batteries for the work stuff, and we'll have more batteries for the stuff. I actually have been thinking about that, Bitloody, like legitimately, right? Is in they're 20 volts, so could you like, you know, power them off this? I don't know what their current draw is. Like, is it more than 3 amps? I don't know. But then maybe I could have my own chainsaw opening videos. You picked up a battery soldering at just £3. Wow. Nice. Coins at the LD battery saga. That's not bad. That's not bad, yeah. I don't know. I'm a big fan of Aldi, to be honest. I like Lidl too, or I like their specials. I probably prefer Aldi as a shop, but yeah. Okay, folks, I'm on kid duty in the morning, so I better go to bed. Thanks so much for joining. I'm gonna order this. I suppose follow me on Twitter if you want to kind of keep, or on my Discord. It'd actually be a better place for this, because I kind of post about this project a little bit there. So if you're interested in keeping up to date on this, I will order some samples and we will build them on a stream in a few weeks' time. And hopefully they work and I don't burn my house down or my TS100, which I really should buy another one of. It should be linked in the description, Aaron. Let me know if it's not. I'll hang around for another second. Oh, I need to order some of these because I don't have these. So I'll add that to my cart to remind me to order them. Because I ordered the other type, but I don't have this type. You want me to buy you a TS100, Bitlooney? Do you have the USB-C stuff? This is where deals get done at 1 o'clock in the morning on a live stream. We'll talk, Bitlooney. We'll talk. All right, cool, Aaron. Right, thanks everybody. I'll talk to you again. Really appreciate you joining. No, fine. We'll talk. Yeah, I'll see you. See you next time. Bye bye.